So I usually just pat him into just the bottom.
Okay.
You shouldn't move. You may move a little bit, but usually they stay still. So I'll put it off center for a bit so I can test the water. So, okay, there was someone in our lab tried testing out putting a Nikon camera on the side so you can actually visualize how far it is from the hydrogel surface, because when you calibrate it,
yeah, it's a little hard to.
Yeah. Let's see. I wonder if I can. I wish there was Zoom on this little laptop. That'd be helpful.
I know.
All right. So you lower the probe into the solution if we're performing unsubmerged, and do not make contact with the sample surface, but make sure the entire probe up to the black screw is submerged. So with the physical knob, just turning it until the black touches the water.
Okay.
At the top of the spherical probe. Oh, I wish this. Maybe if I. Marginally better.
Thank you. Okay.
I want to make sure it doesn't touch the surface of the station. Okay, it's a little. There we go. So it says here that you're supposed to go onto the software, and on the top menu, it says instrument. So you click that, and then you go to calibration, then the sensor. You calibrate the sensor. All right, and then it gives you, it says it's thinking. Show you this. Oh. Doesn't match. Oh, here we go. Is my screen black?
Yes.
All right. So
Very
a bunch of
good.
graphs came up, and it notified me that sensor calibration is complete.
Okay.
That's great. Oh. And so it corrected the force and versus displacement curve within the water. So what it did was it actually ran the program on it in the water alone. Next up. Cool. All right. You go to instrument settings, load cell sensor. Update sensor tear. And so it's thinking. And then as well, there's another button called Calibrate Sensor next to it. So you click that as well. A lot of calibrations. I wonder if I can show you this now. Oh, missed it. But it's that's usually what the plot looks like while it's indenting.
Mm-hmm.
And it looks pretty smooth. So it looks like it's working, thankfully. This piece of machinery is a little
Finicky.
a little moody.
Finicky.
Sometimes it wants to work, sometimes it gives you an e-stop. I'll show you if it happens.
Oh yeah, if you do an e-stop, you gotta start over. It just does it randomly for no reason. I remember that.
Lovely.
Exit.
So don't be in a rush.
Yeah, that's why I usually book like 4 hours for all my samples.
All right, good to know. Book extra time.
So make sure that the noise, there's a thing to talk about here. So the noise, now that it's calibrated, the force should remain between positive and negative 10 for the most part. Micronewtons.
Okay.
So it looks pretty good there. That's what the calibration did to minimize that noise. This says you may need to repeat calibrating the sensor 2 to 3 more times if it's still too large, because the table might have moved or something electrical might have happened randomly to cause it not to calibrate correctly. All right. So for step 4, for running your samples, it says check the force is approximately 0 newtons. So what it means is that you have to make sure that the line, the force curve here is centered at 0. So the running average is 0.
Okay.
Right, and if not, then you can always change the piezo bias here, which automatically pushes it up or down.
Okay. So can you press that 0 button? And then it'll center it to 0, maybe?
Yeah, it should automatically center it, and you can't really see the difference, apparently. But it's a very minute difference.
Yeah.
It doesn't change like how high or low it goes. It just changes like centering. Next up. Sorry, I'm like switching between these two. You need to create a load function, and the parameters you can figure out with past protocols you can find, and then work from there, or you can come up with a brand new one depending on parameters you read in papers or literature, the Simmons paper even. But the general rule of thumb is that the load displacement and how far it just presses into the hydrogel should be approximately 10% of the sample.
Okay.
Or less. Oh, I guess I forgot to do this. But you have in your lab what was it called? Calipers?
Oh, no, but I definitely told Dr. Phelps we needed a caliper.
Nice.
Okay.
So this is very important for your hydrogels because it tells you how thick they are. Because even though your molds might be a certain size, they can vary within. So for this, every single specific sample that we run, we measure their thickness. And I forgot another material, but add this to your list of materials, a slide that we use where we place our hydrogels on top of, and we use that while measuring the thickness. I'll be right back with it. That's long. Yeah, I always forget them.
Hey, yep, you're all good.
So I just got notification that the CII thing is in 15 minutes.
Yeah, it is.
Yeah, so I'll hurry up after it.
No worries. You're good.
So I got the glass slide. We're almost done.
Oh, and there's my notification for it. Oh wait, Brian, it's kind of hard to hear you.
Ooh, I can't hear him at all.
Yeah.
What happened? Oh, he's muted.
Right, what about now?
Yes.
Okay, yeah. You're good.
So, now it's still coming out of my head. Okay. I guess we'll manage. So, let's see if I can show you through here. But I'm going to put a hydrogel on top of this slide right now. Not the one we're testing, but in the future you might want to do the one you're testing. Just doing it for time's sake. Oh. So here she is.
Okay, and you just make you use the like a well plate as a mold, right?
Yeah, I use a 24 well plate because I usually work with n=6.
Okay.
So it works out. Right. So whenever you measure this, with calipers, I want to make sure you zero it first, and then my rule of thumb is whenever the water wicks up and touches the calipers is where I stop measuring.
Okay.
So it doesn't matter really what you choose as your stopping point for measuring, but as long as you're consistent. But so you just close one eye.
Oh, so you do the glass slide onto the top of the hydrogel and then just subtract the glass slide?
Right. So
Okay,
the
that
glass
makes
slide,
sense.
I would measure at the beginning. So the long glass slide would be better because you want to make sure it lands on the thick part of the calipers so it doesn't slip off and it's centered correctly.
Mm-hmm.
2.6. So this one's 2.6 millimeters. With the slide, and then make sure you have a running measurement of the slide, 1.12. So 2.6 minus 1.12. And that's approximately 1.5. So in that case, 10% of that is 150 micrometers.
Mm-hmm.
So you want to make sure your load function doesn't go past 150 micrometers in depressing into the hydrogel. And it looks like this one right here that Mary has loaded up already for GMHA is 130 micrometers. So that works out. Right, so just stick this little one back in there. And let's run this. All right, create a file name. So in the program, of course, put test sample name. Alright. And then the save folder, so you have to click the little folder icon to like before you save it in the computer. So the desktop for now. Alright. And then, okay, this is important. So I'll have the camera on for the computer as well. So when you lower the sample, you actually have to look at the graph while you're manually lowering it with the manual crank.
Okay.
Because you have to lower the probe into the sample up to the point where you see a huge difference in the graph.
Okay.
So I'll show you now what that looks like. So I'm going to put the probe that. I'm going to pick one corner of the hydrogel. It's supposed to be a triangle, so if you were using a dry sample, you might want to mark your petri dish so you remember where you tested before on your hydrogel. Hold my iPad. So I'm going to lower it here, and then I'm lowering it currently. And at some point,
Was that it?
Oh, yeah.
Okay.
it senses a force pushback.
Yep.
So you see here this drop right here in the force?
Yeah.
Now it's centered around like minus 150 micronewtons. That's how you know you're inside the hydrogel. So what you want to do is go back to the top of that, to the top of the cliff that you just formed again. So now go
Okay,
backwards.
so then you bring it back up a little bit.
Yeah, you got to bring it back up to just the precipice of falling off that cliff.
Nice
Back
word.
to
Nice
where it was.
precipice.
This takes some
Oh,
finessing.
my bad. Oh,
This
I
takes some
didn't-
finessing for sure.
All right, let me start over. Oh gosh. I'm like holding my iPad at the same time as. Okay, just.
If you need to actually do it, I mean, we saw like logistics of how to do it. So with the software, so if you need to just do it and put us down for a minute, that's fine.
Yeah.
There we go. I guess that's good. All right. So back to the starting point because I messed up. So I'm starting back at 0. Actually, I was going backwards with the probe. So I'm make sure you're in the right direction. So it's actually going up. Nope, so it looks like that's it.